Alright, you guys, this is page 3 review for Unit 10. What I did here is I went ahead and just kind of wrote your steps for graphing quadratics. Step number 1 is where you start with the axis of symmetry. Okay, and that's going to be the dotted line that we draw. And that helps us know where our parabola is going to reflect across. Then we take step number 2, we take that x value, and that's the x in our vertex, and we plug him back into the original equation to find the y of our vertex, and we plot that point. And it'll be somewhere along the axis of symmetry. And then step 3, you want to plot the y-intercept, which is always the letter c. And remember, your equations look like ax squared plus bx plus c. And c is always the value where it hits the y-axis. Then, if we still need another point, we can pick another value and plug it in. And try and always pick a value that's close to your vertex, okay? So, you might want to pause the tape here and write these steps down and have them handy as we're going over the next few problems. Number 8, graph the quadratic. So, we're going to start with the axis of symmetry. X equals the opposite of b over 2a. In this case, a is 1, b is 2, and c is 8. So the opposite of b is negative 2 over 2 times 1. Negative 2 over 2 is negative 1 for your axis of symmetry. Remember to write that as an equation, x equals negative 1. And you know that's the x value in your vertex. To find the other y value, you take negative 1 and you plug him back in to the original equation. Y equals negative 1 squared plus 2 times a negative 1 plus 8. And you can plug that into your calculator, making sure you have parentheses around what x is. So negative 1 squared is 1, minus 2 is the negative 1 plus 8, 7. So what you want to do is graph that axis of symmetry. X is a negative 1. And that's our dotted line. Does it have to be dotted? Yeah, it should be dotted. So go ahead and make it dotted. Then you want to graph the vertex. Negative 1, 7. It'll be right here. And if you remember our steps, step number 3 is graph the y-intercept. And the y-intercept is always the c. You want to put that point on the y-line at positive 8. The good news is that you can go ahead and reflect this guy across the axis of symmetry, and I'm almost done. I know that it's going to be pointing up because a is positive, so it's going to be smiling, if you will. But I like to have 5 points on my graph, so I'm going to go ahead and plug in one more value. I don't have where x is 1, so that's going to be the value that I choose, where x is 1. And I want to see what y comes out to be, just to give me one more point on my graph. 1 squared plus 2 times 1 plus 8. And when you plug that into your calculator, you're going to get 11. So the next point I'm going to graph is 1, 11, which would be right up here. And you want to reflect that across your axis of symmetry, and then connect your dots. For this graph, we now need to go back and tell, is the vertex the maximum point, like the topmost point, or is it the minimum point on your graph, where it's the bottommost? And in this case, it's minimum. Does your graph open up, like the U and up, or down, like it's frowning? It's going to open up. Your domain is the same for each parabola. In this case, it'll be all real numbers. And then you look at your y values for your range. And you know that your y values, they start at positive 7, and that's your vertex. And then positive 8, positive 9, positive 10, all the way to infinity. From 7, they continue up. And so what we do is we call that y is greater than or equal to 7. And notice they always start with the y value in your vertex. And then they go either forever up or forever down, depending on the way that it's pointing. So we're done with that problem. Remember, you start with the axis of symmetry. Then you plug that value in to find your vertex. Then you graph your y-intercept, and then you pick one more value just to make your graph accurate. So number 9. First, we start with the axis of symmetry. X equals the opposite of b over 2a. Opposite of b is going to be negative 8 over 2 times the negative 1. Negative 8 over negative 2 is where x is 4. So in your vertex, you know x is going to be 4, and you know your axis of symmetry is x equals 4. So I'm going to go ahead and graph that. That's that dotted line straight up and down where x is a positive 4. Then you're going to go back and plug in to your original equation, y equals negative. Notice negative is on the outside of the x, so you leave him outside the parentheses. You plug in 4 squared plus 8 times 4 minus 10. This would be a good example to put it in your calculator just so you make sure you don't make a mistake. Making sure your parentheses are around the positive 4 only. Okay, so my calculator looks just like that. I don't know if you guys can see it. But you've got parentheses just around the 4. And you plug it in just like you see it. And hit enter, and you get a positive 6. So your vertex is 4, positive 6. That would be right here. If you guys remember, the next step we said was to graph our y-intercept. Remember, your y-intercept is the c value. So in this case, y-intercept is negative 10. So it's going to be all the way down here. And you're going to reflect him across, get another point, and then I would go ahead and pick one more value. You could pick where x is 1, 2, 3. We already have where x is 4. You could pick 5, 6, or 7. I'm going to pick 1 because it's the easiest to plug in. So y equals negative on the outside of your parentheses, 1 squared plus 8 times 1 minus 10. So that's negative 1 plus 8 is 7, minus 10 is a negative 3. So positive 1, negative 3. And you're going to want to reflect that across as well. Connect your dot. Notice it's facing down because a is negative. So when you look at your vertex, is your vertex the highest most point or the lowest most point? Well, in this case, it's the highest. Is it opening up or down? This one's going to be opening down. Notice your arrows are pointing down. Your domain is still all real numbers. And then your range, you want to say where y is less than or equal to 6. Notice it starts at 6 and then it goes all the way down for infinity. All those y values, they're less than or equal to 6. Notice we still use that y value of your vertex, and this time it's going to be all your y's that are less than that vertex. Okay? That is the end of page 3 for your Unit 10 review.